How are you all? This is your ma'am Akshita, and I would like to welcome you all to the DPP discussion introduction video of the chapter hydrocarbons. Let's start off with the very first question. So they're asking us to find out the correct order of increasing acidity. So what you need to keep in mind is acidity. When you talk about acidity, what comes into our mind? Two things. Okay, firstly, the first thing that you need to look out for is whether the carbon is sp hybridized, sp2 hybridized, or sp3. In that case, sp is going to be more than sp2 is going to be more than sp3. We have already learned this, we have already understood this, that more is the percentage of s character, more will be the acidic nature. That is the first thing. Next thing that we need to search for is there a presence of minus I or plus I group attached? We know minus I group is directly proportional to acidic nature, whereas plus I is inversely proportional to acidic nature. Alright, now keeping these 2 points in mind, when we look out for our perfect option, it happens to be option 4, because as you can see, the first one is acetylene, sp hybridized carbon is there. Then in the second one also, which we have happens to be propyne, is also having sp carbon. But the problem is it is going to be less than this one and more than ethene, because there is R group attached, which is a plus I group. That is why it is going to be less than acetylene but more than ethene. Then we have ethene, which is having sp2, and finally ethane, which is sp3. So option 4 sits well with us. Next question is identify Z in the given reaction. So you look at this particular reaction, HBr in the presence of H2O2. The moment you see hydrogen halide, okay, specifically hydrogen bromide with peroxide, what needs to come to your mind is anti-Markovnikov rule, or Kharash effect, or peroxide effect, wherein generally what we go for is, this is nothing but CH3 CH2 CH double bond CH2. What you will observe over here is electrophilic addition reaction. The electrophile, now in HBr, what is the electrophile? H plus is the electrophile and Br minus is the nucleophile. Now electrophile addition reaction means that the electrophile is added first. The electrophile is added first. Now the question is, how does the bond breakage take place? It will take place in such a way that the secondary carbocation is formed, and this is Markovnikov rule, that the more stable carbocation forms the major product. So technically, sorry, one second. So technically, the bond breakage should be like this. However, since only in the case of HBr in the presence of H2O2, the reverse of Markovnikov rule takes place. That is, the less stable carbocation forms the major product because of free radical mechanism. Alright, as a result of which, the bond breakage is going to take place like this. Alright, as a result, this is getting the negative charge, this is getting the positive charge, and what we get is CH3 CH2 CH Br CH, sorry, CH Br CH2 Br. Let me write it nicely so that it's clear to you guys. Yeah, so it is going to be CH3 CH2 CH 2, because the hydrogen attacks over here, and to this H plus Br minus will attack, so CH2 Br. This is what we are getting. Now this is our Y. To this Y C2H5ONa is going to react. Now this is nothing but sodium ethoxide, right, where sodium gets a positive charge and the ethoxide gets a negative charge. Over here this is getting a positive charge and this is getting a negative charge, right? So this Br minus is now substituted by C2H5ONa. Basically this is nucleophilic substitution reaction that is taking place over here. As a result, you will get CH3 CH2 CH2 CH2O C2H5. Basically we are getting an ether, right? I can also write this as CH3 CH2 taken thrice O C2H5, which happens to be our fourth option. There we go. Moving on to the next question, beta. The product obtained on heating 2-bromopentane with potassium ethoxide and ethanol is. Now, what you need to keep in mind over here is there is ethanol, alcoholic potassium. Okay, when a potassium ethoxide in the presence of ethanol, what you will get is you'll get alcoholic KOH. What you need to keep in mind is alcoholic KOH always shows beta elimination reaction. So when you look at bromopentane, 1, 2, 3, 4, 5, right? 2 bromopentane, that is bromine is on the second carbon. Now this is also a beta carbon. This is also a beta carbon. Now, which beta carbon will it react with? This one, Sazef rule beta. That is why CH3, CH2, CH double bond, CH, CH3. This is what we get. Now the question is, we have gotten pentene. It is definitely not pentene. It is definitely not 2-ethoxypentane. Now the question is, are we going to get cispentene or transpentene? Now in this case, what you need to understand is trans is more stable than cis because of symmetry. Thereby, trans will be formed as a major product always. Alright, moving on to the next question. Choose the process by which liquid hydrocarbons can be converted to gaseous hydrocarbons. This is a direct question. Direct answer is cracking. Moving on to the next question. Which one of the following halide can be used in Friedel-Crafts reaction? For Friedel-Crafts reaction, it is very important that a carbocation is formed, because Friedel-Crafts reaction is nothing but electrophilic substitution reaction. Sorry. Wait a second. No, not electrophilic. It's only in the case of benzene that it is electrophilic. But Friedel-Crafts reaction needs to form a carbocation. Now, in the case of bromobenzene, chlorobenzene, and chloroethene, in all these cases, we will not have a carbocation because there is conjugation. Okay, there is conjugation. So the presence of carbocation is not present possible over here. Whereas over here, for isopropyl chloride, that is CH3, CH, CH3Cl. This can definitely form a carbocation. Thereby, this will show the reaction. Moving on to the next question. Which one of the following compound forms salt on reaction with sodium amide? This is very easy. Okay. Now look at acetylene. Acetylene will undergo reaction with this because the sodium is displaced beta. And for that, H plus needs to be displaced. And since this is sp carbon, this will let go of its H plus very, very easily. So when this reacts with NaNH2, what we get is H, C triple bond, C, Na plus NH3. Now this can further give rise to bigger alkynes. Thereby option 1 is the answer. Moving on to the next question, beta. Which among the following reagent can be used to distinguish between, okay, primary and secondary silver nitrate? This is a direct question. Moving on to the next question. Isopropyl iodide is formed after reaction of propene with HI. This is due to, again, this is following what, beta? This is following your Markovnikov's rule. Okay, and isopropyl iodide is formed because when you look at HI, what we get is H plus plus I minus. Okay, now when you look at propene, okay, C C C double bond. Okay, now this is, sorry, we need a stable carbocation, right? Do we not? The bond is broken like this, so we'll get C plus, C minus. Now to this, H plus will attack. Let's see, C, H. To this, iodide will attack. We'll get C, C, CHI. So the reason is stable carbocation. Moving on to the next question, beta. C6H5CHO is formed when C6H6 is treated with CO in the presence of HCl. This is Gattermann-Koch reaction. The moment you see carbon monoxide with HCl, it is Gattermann-Koch reaction. That is when you're taking benzene, beta, and you're reacting it with CO, HCl in the presence of AlCl3, you will get benzaldehyde. This is the preparation of benzaldehyde. Moving on to the next question. A compound having a bond angle of 180 degrees, sp hybridization will have a bond angle of 180 degrees, thereby alkyne is the answer. So with this, kids, we have come to the end of our session. I hope you were able to understand the solutions. However, if you have any doubts, you can always reach out to me in the first 10-15 minutes of our class, or maybe in the last 10-15 minutes, according to your convenience. All right then, kids, with this, I shall meet you in the session. Until then, keep smiling, keep revising, and stay healthy. Bye bye.